Hi, welcome. I am Jeffrey Stein, CEO and founder of Deep Discovery. And today I'm going to be presenting what we're doing at Deep Discovery and an example analysis of the Russian Laundromat with my colleague, Gabrielle Simeone, who's data science on our team here. And so yeah, let me just jump right into it. Deep Discovery has built a knowledge graph of 3 billion entities, companies, directors, officers, shareholders, registration agents of the world's companies around the world, drawing from 150 nations, corporate registry databases. And our aim is to root out financial crime using the power of graph analytics. We're going to today walk you through how we're leveraging TigerGraph for this. But let me give you a little bit of context. Today, banks and financial services companies are required by law to do KYC screening, so know your customer due diligence of all of their clients. And they're looking them up through simple search-based methods against databases, government databases of known bad guys, financial criminals, people that have been sanctioned, and a variety of other adverse activity. Now, the problem is that the financial criminals often know that they're in these databases. So a lot of the times they're not opening bank accounts in their own name. They're doing it through offshore shell companies in the British Virgin Islands, in the Bahamas, in Cyprus, all over the world to hide their money in secrecy, their ill-gotten gains. So Deep Discovery is devoted to rooting this out through the power of graph analytics. We do this with a network-based risk scoring approach, where risk is inherited by one's neighborhood. If you're an agent of a Russian oligarch, that will show up in our app and be very powerful for your compliance needed at these financial institutions. So I want to jump into a demo first of what we're doing at a high level, and then we'll talk about the Russian Laundromat, which, as some background, was a case that was reported by the Organized Crime and Corruption Reporting Project, which is Europe's leading investigative news organization. They uncovered $150 billion of money laundering, primarily out of Russia, that went through small banks in Latvia and Lithuania, and then spread all over the world through shell companies. So Gabrielle will walk through some specific examples of that, but let me just orient you first by sharing my screen here of some broad examples. So imagine somebody named Ivo Zudis is going to open a bank account at your favorite global bank. We get a list of search results of different Ivo Zudises around the world, from Latvia, Croatia, Netherlands, Brazil, France. We've risk rated them all on a 100-point scale. Now, the bank will have identifying information through a passport or driver's license or employment information, which allows them to filter down to the specific client that is theirs and get a summary card of the most highly risk-rated entities linked to that client, Ivo Zudis in this case. We also see any adverse media that comes up along with summaries of risk classification tags. Now, if one drills down, we get a network view of the client, here connected to about a dozen companies. We see the roles he has with each of the companies, the risk scores those companies have, and the percent contribution they make towards Ivo Zudis's own risk score, along with any adverse media that's been found, where we've color-coded by risk, the entities found in the articles, and risk classification tags. Now, if one was trying to do this by manual methods, as is typical today, one would actually find in the corporate registry databases 4 different records of Ivo Zudis that are linked to the various different companies that make up this overall network. But it turns out these 4 different Ivo Zudises are actually the same person based upon common address, common dates of birth, also something called co-reference resolution, where we look at common directorships. My own name, Jeffrey Stein, is very common, but if I serve on the board of Deep Discovery with Gabrielle Simeone, and if we also serve on the board of another company together, the likelihood we're 2 distinct pairs of people that happen to have the same 2 names is very low. And so we use deep learning methods to do this entity resolution, which is very important for weeding out false positive matches of common names. We resolve them to common globally unique identity, and this allows an analyst to focus on the underlying evidence that makes up the risk score. In this case, there's a single news article on the internet that mentions Ivo Zoudis, where he's incorporated 3 companies described as front organizations. The other front organizations also have adverse facts appended to them in the network here. And what stands out in this particular network is one gray node. A gray node is an intermediary node to a red node, where in this case, Ivo Zoudis is a member of the board of Limburg Industries in the Czech Republic, which itself is a branch of Limburg Industries in the Seychelles, which is linked to other red nodes. We can inspect the reason why it was designated a red node, in this case, because it's on the US Treasury Department sanctions list. So we can click through to the underlying source record, which is very important for provenance and audit purposes. And there's also adverse media here. Now we're using natural language processing to do automated information extraction from billions of news articles. In this case, we can drill down into the newsreader view. We could read the article from top to bottom, but often articles are long or they're drawn from government reports or court record documents. So we can also step through the various adverse facts. And as we do, we keep the network context in the lower left here, which is very important because we're pulling facts, not just about Ivo Zoudis, but as his extended network. So for example, here's an adverse fact about an aircraft with a tail number VPCSP that was sanctioned by the US Treasury Department and listed the plane as belonging to this man Yevgeny Prigozhin via Limburg Industries in the Seychelles, which was a shell company that had a branch in the Czech Republic that was incorporated by this Ivo Zoudis along with several other related companies, the same ones we saw in the network view. And this was all done on behalf of the Russian businessman Yevgeny Prigozhin, who was sanctioned and indicted by the US for his control of the Internet Research Agency, which was the troll farm at the center of the hacking of the 2016 presidential election. So this man was sanctioned. He has a risk score of 100 on our 100-point scale. There are many more adverse facts about him drawn from a variety of news articles. And if we expand his network, we can see that he's connected to 15 different sanctioned entities, including controlling that Internet Research Agency, which itself is linked to another dozen sanctioned people. So in the real world, these sort of people, the Yevgeny Prigozhins, are unlikely to be opening bank accounts at prominent banks. They're doing it through offshore shell companies and frontmen like this Ivo Zoudis. So we've designed a system from the ground up to identify the frontmen, the enablers of financial crime, which is where the activity actually really occurs. Now, as we expand out networks, we can easily, starting with one searched entity, get up to 1,000 entities from 3-4 hops out analysis. So we also have ways of curating the graph and with flowcharts to show the most material flows of risk that clearly identify that in this case, Ivo Zoudis is inheriting his risk primarily from Yevgeny Prigozhin. So now that you have a underlying basis of what deep discovery is doing, I want to turn it over to Gabriel, who's done analysis with the Russian Laundromat, specifically to identify the enabler firms with that. So let me stop here and turn it over to Gabriel.
Thank you, Jeff. Thank you so much for the context and the presentation. If I may, I'd like to add a couple of more minutes of context before we dive into today's research question, which is how can we leverage TigerGraph syntax and graph analytics to identify what Jeffrey has called is enablers. We call them rogue enablers, which are the enablers who went rogue and they are at the service of organized crime. As Jeffrey was saying, our data is coming from a knowledge graph of roughly 3 billion entities, which have been resolved via deep learning and deep entity matching into roughly 2.4 identities. And the data that we're going to work with today is a part of this graph, is a subgraph of this. This subgraph has been built by starting from a certain number of seeds nodes that we called sunflower. And the sunflower seeds, they comprise of 2 sets. On one hand, we have the politically exposed people and the sanction targets of Ukraine, Russia, Belarus, and Cyprus. And on the other hand, we have the top senders and receivers and the entities associated to Cyprus from the laundromat data that Jeffrey has just described. We then, from the sunflower seeds, we did a 4-hop expansion. So we walked out 4 hops, and we resulted into roughly 20 million identities. Now, what I want to show you is that I want to show you how we can use TigerGraph to find what Jeffrey has just showed you from Iva Zudis, this frontman, in using TigerGraph and Deep Discovery app. But before getting into that, it's useful to define one more thing, which is, what are these enablers? What are these these intermediary people and companies that are often involved in money laundering? To understand that, it's useful to take one quick step back in how money laundering is worked and how we generally think about it. So it's structured in 3 phases. There is the extraction phase, in which there is an oligarch or an organized crime. There is some corrupt individuals, and there are proceeds of crime. And then these proceeds of crime needs to be laundered through the financial system so that they can be integrated again as clean money, so that the original criminals can then enjoy them and, you know, buy yachts, assets, mansions, elite education, and whatever. We are focusing on the second step, the step in which the money is coming from the acquisition phase, is being laundered and going out into the integration phase. In this step, there are a lot of intermediaries whose job is to create this opaque and complex network of companies, which are often 95% of the cases using shell companies in secrecy jurisdictions, in order to distance the source of the corrupt source of the money from the money itself, so that it's been parceled up, go through the financial system in this opaque way, and then it goes back into the economy, being integrated. These enablers that we're interested in are especially technically called TCSP, to a trust and company service provider. Now, a TCSP is defined by what they do. It's not something like, you don't have a license for being a TCSP. So a TCSP is just someone who is offering services such as forming companies, providing a registered address, a business address, acting or arranging for another person to act as a trustee or a nominee shareholder. But most of the time, they are acting as director or secretary of a company under an arrangement with a person other than the company itself. So now that we have this context, let's see how we can translate it into a TigerGraph query using our data and see what comes out and visualize it in our application. So I'm going to start from this first query, which is find rogue enablers number 1. I'm not going to go into the deep dive into the you know, all the accumulators, but I'm going to show you in this query where the logic that I just described becomes code. So the first thing that we're going to do is that we're going to use what I call a top-down approach. So we know how the high level functioning of this enabler. Let's see if we can query the graph and find what comes out. So these are the edges types that we're going to walk through, and you're going to recognize what I just described as the activities of these trust and company service providers. We're going to start from our from our sets. And what we're going to do is that we're going to simply do a walk, a simple one edge walk, so that we can count the degrees of companies, was edge type is in these TCSP edge types, and then we're gonna record this into a set. Now, the problem is that this is going to yield millions of results, because being a TCSP is just a normal thing. It's nothing dodgy per se, but the way in which we can weed out some of these false positives is that we can record how many times in a 2 hops expansion from these TCSP-like nodes we hit a politically exposed person or a sanction target. So this is what we're doing here. We're doing a 2 hops, TGT1 and TGT2, target 1 and target 2, and then we're checking whether target 1 or target 2 is a PEP or a sanction. We're recording that in a vertex attached accumulator, and we're counting it, getting the size, and then we're making sure that we filter by having at least 50 sanction or PEP hits along the path, And then we basically get our results in a descending order. I've already run this query and I prepared a little JQ play here for us. And we can see some of these initial results. We can see definitely that there are some of these companies which have really a lot of hits, like it means that in the 2-hop expansions, they met a lot of sanction orbit. Well, in this case, it's just sanction. We can also see that these are big names like CT Corporation Systems is a register agent solutions. These are big conglomerates. It doesn't mean that these conglomerates, they are entirely, their business model is helping Russian oligarchs launder money out of Russia. It just means that there is something dodgy going on in their 2-hops expansion that hits a lot of sanction. But we have to imagine that these have hundreds of thousands of clients, and we cannot just label these, too big to be all risky, and anybody who is connected to them is risky. So we can already see how this kind of top-down approach, it takes us somewhere. There definitely is more scrutiny needed for this kind of corporations and the clients of the clients of the clients, but it only takes us thus far. It's not a super actionable insight. To get more actionable insight, I want to propose you a second kind of query, which is instead leveraging what Jeffrey was talking about, which is the laundromat data. You have to imagine of the laundromat really just as a kind of a TOR network for corrupt people, in which anonymity is almost assured by such a high complexity and secrecy of these Russian dolls like company structures, that if we get access to the data is invaluable signal for us that can shortcut us through finding some of these enablers. And that's what we're going to do. And because these are such opaque and nested often structures, what we're going to do is that we're going to look for cycles in it. So you remember that we start from these sunflower seeds, which contains the laundromat and contained the sanction and PEP from this 4 jurisdiction that I mentioned. And what we're going to do in this line, which is very important, is that we're going to look for like intermediate companies between 2 sunflower nodes. We do that because often case we have shell companies or shelf companies that are being recycled by people or nodes, let's say, that are in the same corrupt network. And so they use them, they exchange them with each other. So what we're going to do is that we're going to find all of these intermediaries, and then we're going to focus on Cyprus for 2 reasons. First reason is because Cyprus is a tinier country, so we get less data and it's easier to analyze. And the second reason is because Cyprus is notoriously a money laundering hub for former USSR kleptocracy and oligarchs. Another thing that we're going to do is that we're just counting the degree and storing them in a vertex attached type, getting degrees above 10, and then we're getting them in descending order. And here as well, and then we're going to print them and we're going to call them intermediaries. And I also just stored this result already, and this is these are some of the results. We can already see that we have a lot of holdings, a lot of limited companies. If we scroll down, you're going to see a lot of LLPs and PLCs, which are typically the structures of, the legal types of shell companies. I highlighted this because this is the first probably enabler that we just found. And I know for experience that generally these companies, these TCSP, they have very obvious names, like this one, Page Directors Limited. I know of another one which is called Secretaries Limited or Temple Secretaries Limited. They really have this kind of like, very obvious name that, kind of say what they do. And I pulled out this company, Page Directors Limited, in our application here, that you can already see that it has almost 100% score. And the reason for that is that our risk score, as Jeffrey was saying, propagates risks from neighborhoods. And we can already see that Page Directors Limited is connected to 2 sanction nodes with 1 direct hop. It's connecting to Sberbank of Russia, which should be sanctioned. And this is probably, voila. And so exactly, so this is probably just an associate of the actual sanction entities from Sberbank. And then we actually dug into this a little bit earlier, and we found that via Zinbergo, we're going to find an oligarch. Here he is. We have Oleg Vladimirovich Deripaska, who is a an oligarch who had been associated with the Trump-Russia scandal. One last thing that I wanted to show you in this, in this network, is that we have here a company, this Preserva Ltd, which is probably another shell companies. And then if we expand it, we see the typical behavior of enabler. So we have an enabling company here, page directors, with its directors and shareholders. They form another company, which is a shell company. And then this company is being lent to another bunch of clients, or, as director of, acting nominee of. So this basically hints us two things. It hints us that an enabler is called a rogue when the proportion of its clientele and its neighborhood is high risk. This is something that we can know because we have this risk propagation algorithm in deep discovery. And the second thing is that it's probably useful from this list of intermediaries that we've already built in this query to do another hop and see what we can find. So I built this second step queries. This first part is what you have already seen before. It's just the intermediaries connecting two sunflowers. But then let's do another hop from these intermediaries, but without any restriction now. Let's see just one hop outwards and see whatever they connect to. Let's always focus on Cyprus. Let's always focus on only companies and order by degree. And I call them these potential Cyprus TCSPs. And also here I have a JQ play. Interesting, we can already see that if we start expanding, we see that it's connected to big financial institutions like the Bank of Cyprus. And then we start seeing, as I was saying, these nominees popping up in the names. It's very obvious. ATS Nominees Limited is a very known rogue enablers. And I wanted to pull out Laxo Services Limited because it's a very interesting case study for us. I'm going to refresh the page so we get all of the nodes. So it has many more connections than it's showing here. That's 87, but we can expand by double clicking on it several times. At least we should. Yes, voila. We get more and more. You see more and more connections. So high connectivity. That's what I mean. And then we can focus on the red nodes that we have here. So Key and Management Ltd, I can tell you because we looked into the data, is a laundromat. It took part to transactions in the laundromat data. And then it's not a sanction per se, but it's linked to a sanctioned entity called Primex Business Consultants Ltd. And then pretty much all the network of Primex is dependent on these two nodes, Mudala Kuri and Nikos Nikolaou, who have been sanctioned because they were basically helping the Russian government buying oil from the Islamic State.
The Syrian government.
The Syrian government, yeah. Sorry, what did I say? Anyways.
Russia was involved, but it was on behalf of the Syrian government. They were buying oil from ISIS, of all people.
Exactly. Thank you, Jeffrey. Yes, thank you. So yeah, here we have another clear example of what constitutes a rogue enabler and how we could find it using TigerGraph, which is starting, from the leads that we got initially out of TigerGraph. We expand the network and we again find that they're connected to pretty obviously dodgy companies that are most likely to be involved in money laundering. So yeah, this was the presentation, and I hope that we showed you how you start from what we know of how this works, how we can write a top-down query and where does it get us, what are the shortcomings of that, and then how we can leverage corrupt signals such as the laundromat or any other corrupt transactions that a bank might have to basically cut through the noise and find this incorporation agents, these enabler TCSPs. So this is the end of my presentation, and we're going to be around later on for Q&A if necessary. Thank you.